Hello, students. In my last lecture, I have discussed about inventory models with probabilistic demand. Today, I am going to discuss inventory models with price breaks, or we can say that with quantity discounts. In the inventory models discussed in my previous lectures, so far the production or purchase cost per unit was assumed to be constant. It was not considered during their formulation since it did not affect the level of inventory. In this lecture, we shall consider a class of inventory problems in which this cost is variable and depends upon the quantity manufactured or purchased. This usually happens when discounts are offered for the purchase of large quantities. These discounts take the form of price breaks. For better understanding, let us consider an example. The price breaks The price breaks may be given as rupees 1 per item for purchase of items up to 500, rupees 0.95 per item for purchase of items up to 1000, rupees 0.90 per item for purchase of items up to for purchase of items 1001 and more 1001 or more. Now the purchase cost is a variable and is given by purchase cost. CQ is a variable and is given by the expression 1 into Q when Q lies between 0 to 500, including 0 and 500, 1 into 500 plus 0.95 into Q minus 500 when Q lies between 501 to 1000, including 501 and 1000, and 1 into 500 plus 0.95 into 1000 minus 500 plus zero point 0.9 into Q minus 1000 when Q is greater than equal to 1001. Now this is the purchase cost, and purchase cost is a variable here. Such a variable cost must be considered in the inventory model. Further, as this variable production or purchase cost per unit is more appropriate for purchase part because of quantity discounts, we shall hereafter refer only to purchase part, and the problem then is to determine number one, how often the parts to be purchased, how often the parts be purchased Number two, how many units should be purchased should be purchased at any one time. Now the problem is to determine number one, how often the parts be purchased. Number two, how many units should be purchased at any one time. Now I am going to discuss inventory models with the price breaks one by one. First, I am going to discuss inventory models with one price break. To understand how the optimal order quantity can be determined in such a case, let us consider one example. Here, the example is an automobile manufacturer purchases 2,400 castings over a period of 360 days. This requirement is fixed and known. These castings are subject to quantity discounts. Ordering cost is rupees 70,000 per order and storage cost per day is 0.12% of the unit cost. Determine the optimal purchase quantity if the supplier has offered the following unit prices for the casting. Unit price rupees 1000, for quantity less than 1000, unit rupees 950 for quantity greater than equal to 1000. First, we calculate the economic order quantity corresponding to the unit price of castings. Now, the economic order quantity is given by the formula economic order quantity. Economic order quantity is given by the formula 2 capital R C3 upon C1. Now, what is capital R? What is capital R? Capital R is uniform rate, uniform rate per unit time. Capital C3 is ordering cost, ordering cost to place an order. Capital C1 is cost of holding, cost of holding one unit in inventory, in inventory in inventory for a unit of time, for a unit of time. Now, according to our question, we have given ordering cost is rupees 70,000 per order. That means capital R is 70,000, capital C3 is, we have given in question, an automobile manufacturer purchases 2400 castings over a period of 360 days. That means ordering cost is 2400 upon 360. Then C1 is holding cost, and holding cost is given as, ordering cost is rupees 70,000 per order, and storage cost per day is 0.12% of the unit cost. That is, C1 is 0.12% of unit cost. Now, first we calculate first we calculate the economic order quantity if the unit price of unit price of castings is castings is rupees 950. Therefore, economic order quantity for unit price of rupees 950 is given by square root 2 capital R C3 upon C1. We have R as 70,000 and C3 as 2400 by 360, and C1 as C1 as 0.12% of unit cost. That is 0.12% of unit cost. Here in this case, unit cost is 950. After calculation, we will get economic order quantity as 905 units. Therefore, the manufacturer should place order for 905 units. But this will not be acceptable to the supplier, since he will charge rupees 950 per unit only if the order is placed for 1000. Here 950 is acceptable, charge rupees 950 per unit if the order is placed for 1000, that is q is greater than equal to 1000. Therefore, in our case, economic order quantity which we get is 905 units. Therefore, the manufacturer should place order for 905 units. However, this will not be acceptable to the supplier. Why so? Since he will charge rupees 950 per unit only if the order is placed for 1000 or more units in an order. Therefore, this is an infeasible solution. This is infeasible solution. Why so? Because because the manufacturer the manufacturer should place order for 905 units, but this will not be acceptable to the supplier, since he will charge rupees 950 per unit only if the order is placed for 1000 or more units in an order. To avail unit price of rupees 950 per unit, the manufacturer must place an order of at least 1000 units. To avail unit price of rupees 950, the manufacturer must place an order of at least 1000 units. Now the total cost per day for for order quantity of 1000 units is equal to Q by 2 capital CI plus capital C3 R by Q plus capital CR. This formula I have discussed in inventory model, in deterministic inventory model, classical economic order quantity model. This formula I will pick from classical economic order quantity model. What is I? I is inventory, and C3 I already discussed, capital R I already discussed. What is Q? Q is the quantity, how many units we order. This is order quantity. Now we have order about 1000 units, therefore Q is equal to 1000 into 2. Capital C is How many charge for this order? The charge is of 950 rupees and inventory is 0.12 of 12%, that is 0.12 by 100, plus capital R is C3 is C3 I already discussed, that is 2400 by 360. Capital R is 70,000 and Q is 1000 plus C into R plus C is 950 and R is 2400 by 360. After calculating this, after calculations, we get it as rupees 7370. Now let us calculate. Now let us calculate economic order quantity if the unit price of costings is unit price of castings is rupees 1000. Now we will do similar calculations. Economic order quantity for unit price of rupees 1000. We have also discussed the formula for the same, 2 capital R C3 upon C1. This is basically 2 into 70,000 into 2400 by 360 upon, this is 0.12% of unit cost. Now unit cost is 1000 rupees. After calculation, we get it as 882 units. Now we will calculate the total cost per day for order quantity of 882 units is Q by 2 capital CI plus capital C3 capital R by Q plus capital C into R. Now Q is 882 upon 2, C is 1000, I is 0.12% plus C3 is 70,000, capital R is 2400 by 360, Q is 882 plus C is 1000, R is 2400 by 360. After calculation, we get rupees 7725. Since the earlier cost is lower, therefore the optimal order quantity is 1000 units. Since the earlier cost earlier cost 7370 is lower, the optimal order quantity is 1000 units. This is how we determine the optimal order quantity in inventory models with one price break. What we have done, we first calculate in economic order quantity when the unit price is 950. When we have calculate economic order quantity for unit price of 950, it comes 905 units. But this is infeasible solution. Why so? Because here the or optimal order quantity must be greater than equal to 1000. But in our case, economic order quantities is 905 units. So this is infeasible solution because the manufacturer should place order for 905 units, but this will not be acceptable to the supplier since he will charge rupees 950 per unit only if the order placed is for 1000 or more units in an order. To avail unit price of 950, the manufacturer must place an order of at least 1000 units. Therefore, we calculate total cost per day for order quantity of 1000 units. After calculating, it comes rupees 7370. Now, after that, we will calculate for economic order quantity if the unit price is 1000 rupees 1000. We calculate economic order quantity when the unit price is 1000. When we calculate economic order quantity for unit price of rupees 1000, it comes 882 units. And after that, we will calculate we calculate total cost per day for order quantity of 882 units, and it comes rupees 7725. Now because the cost in earlier case is lower, therefore the optimal order quantity should be 1000 units. This is how we determine the optimal order quantity in inventory models when one price break. There must change. This is basically R, and this is C3, that is order ordering cost 70,000 per order. This is by mistake. This is ordering cost is rupees 70,000 per order. Therefore, C3 must be 70,000, and capital R is given as an automobile manufacturer purchases 2400 castings over a period of 360 days. Therefore, capital R uniform rate per unit time is 2400 by 360. Please change these two entries. Now I am going to discuss inventory models with with more or multiple price breaks. These are inventory models with multiple price breaks. Sometimes the supplier may offer more than one price breaks. The solution procedure for such problem is the extension of that used for single price break. That is, we first determine the economic order quantity with the lowest cost price if it is feasible, that is, if the value falls in the slab of the lot size for this cost price, then this is optimal order quantity. If it is infeasible, we determine economic order quantity with the next lowest cost price. If this too is infeasible, the next lowest cost is tried. The procedure is continued till the feasible economic order quantity is obtained. The total cost corresponding to this quantity level is then calculated. Also, the total cost of order quantities corresponding to cutoff points of the subsequent cost prices is calculated. The quantity corresponding to the minimum of these total cost is the optimal order quantity. For better understanding of inventory models with multiple price break, and for better understanding of this process, let us consider one example. Here is the example. Find the optimal order quantity for a product when the annual demand for the product is 500 units. The cost of storage per unit per year is 10% of the unit cost, and the ordering cost per order is rupees 180. The unit costs are given below. Here are multiple price breaks. If the order quantity lies between 0 to 500, then unit cost is 25 rupees. If it lies between 500 to 1500, then unit cost is rupees 24.8. And if it lies between 1500 to 3000, then the unit cost is rupees 24.6. And if it greaters than 3000 or equal to 3000, then unit cost is rupees 24.4. Now we have to decide the optimal order quantity in this question. Here we proceed as we proceed in the last example, that is inventory model with one price break. We proceed in the similar way. Here capital R is 500 units, I inventory is 10%, that is 0.10. Capital C3 is ordering cost per order is rupees 180. 180. Now first we calculate economic order quantity. We start from lowest cost. First we calculate economic order quantity for unit price of rupees 24.40. This is given by the formula 2 capital C3R upon C1, which further equals to 2 capital C3R upon C into I, which further equals to 2 capital C3 is 180, capital R is 500 upon capital C is 24.4 into capital I is 0.10. After calculation, we get it as 271.6 units. Now This is again not a feasible solution because this unit price is when economic order quantity is greater than equal to 3000. Therefore, this is not a feasible solution. This is not feasible. This is not feasible because the unit price of rupees 24.40 is not available for an order size size of 271.6 units. Now we will calculate economic order quantity for unit price of rupees 24.60, which is next higher cost. This is also calculated in a similar way, equal to square root 2 C3R upon capital CI is equal to 2. C3 is 180, R is 500, capital C is here 24.6, and inventory is zero point 0.10. After calculation, we will get 275 270.5 units. This is also infeasible. Why so? This because this unit price is available when the order quantity lies between 1500 to 3000. Now in our case, order quantity is 270.5 units, therefore it is infeasible. Now we calculate economic order quantity for unit price of rupees 24.80 in a similar manner. This is square root of 2C3R upon capital CI. 2 C3 is 180, R is 500. Here capital C is 24.8 and I is 0.10. After calculation, we will get 269.4 units. This is again infeasible. Why so? Because this unit price is available when the order quantity is between 500 to 1500. So this unit cost is not available for 269.4 units. Now we will calculate economic order quantity for unit price of rupees 25. This we will get in a similar manner, that is 2 square root 2 C3R upon CI. 2 C3 is 180, R is 500 upon C is 25 into zero point 0.1. After calculation, we will get it is as 268.3 units. Now this is feasible. Why feasible? Because this unit price is available for order quantity lies between 0 to 500, and our economic order quantity is 268.3, which lies in the same range. Now we will calculate total annual cost. Total annual cost for order quantity of 268.3 units. It is given by the formula square root 2 C1 C3R plus CR. This formula I take it from inventory model with deterministic demand, that is economic order quantity model, which I have discussed in my previous videos. Here it is square root 2. Here C1 is, this is C1, this is corresponding to 25 rupees cost, that is 25 into 0.10. C3 is 180, capital R is 500, plus capital C is 25, capital R is 500. After calculations, we get we will get 13170.82. Now we will calculate the total annual cost for cutoff points, that is total annual cost for quantity corresponding to corresponding to cutoff points. First cutoff point is about of 500 units. What is cutoff point? Here it is cutoff point. Here first range is up to 500, and then it starts from 500. Therefore cutoff point is 500. Next cutoff point is 1500, and next cutoff point is 3000. Therefore, now we will calculate the total annual ordering cost for these cutoff points. The total annual cost for quantity corresponding to cutoff point of 500 units. This is given by the formula Q by 2 C1 plus C3 R by Q plus CR. Q is here 500 by 2. C1 is C into Y. Here corresponding to 500, the cost is unit cost is 24.8, and inventory is 0.10. Therefore C1 is 24.8 into 0.10 plus C3 is 180 R is 500, Q is 500 plus C is 24.8 and R is 500. After calculations, we will get it as rupees 13200. Now, similarly, we will calculate total annual cost for quantity corresponding to cutoff points of 500 units. Similarly, we will calculate total annual cost for quantity corresponding to corresponding to cutoff point of 1500 and then 3000 units. Now total annual cost for quantity corresponding to cutoff point of 500 units is equal to rupees 14745. Total annual cost for quantity corresponding to cutoff points of 3000 units is equal to rupees 15890. This we will calculate in a similar manner as I calculated above, since the total cost is minimum at Q naught is equal to, here for 3000 units cost is 15890, for 1500 units cost is 14745, for 500 units cost is 13200, for 268.3 units cost is 13,170.82. The lower cost is this. From all the costs, the lower cost is this. Therefore, optimal order quantity is 268.3 units. Since the total cost is minimum at Q naught is equal to 268.3 units, 268.3 units. Therefore, optimal order quantity is 268.3 units. This is how we calculate optimal order quantity in inventory models with price breaks. In the next video, I will discuss about queuing theory. Till then, thank you so much.